Welcome back to A Slice of Physics. In the previous video, we discussed the concepts of distance and displacement. And now we will look at the related concepts of speed and velocity. As you know, speed is a scalar. It's the total distance traveled by the duration of the travel. Velocity, in contrast, is a vector, and as a vector, it has magnitude and direction. Velocity is defined as the displacement divided by the duration of travel. As usual, let's take some examples to explore these concepts. The example we'll work with today is my hypothetical walk along three sides of our classroom. Let's say I start over here, and first I walk right along the wall, then I turn left and walk up to the other end, and then turn left again and walk to this corner of the room across from where I started. So here's my starting point and here's my ending point. And let's say the room is such that this length here is 12 meters, and then the one that I walked upward is 15 meters long, and then assuming a rectangular room, I walked 12 meters to the left to my ending point. And let's also say that the first segment took me 6 seconds to complete. The second segment took me 5 seconds to complete. And the third segment took me 4 seconds to complete. Okay, there's all the information of the walk. And our goal is to find out the speed for each segment of travel as well as the average speed for the entire journey. And we're going to do the same thing for velocity, but only for the first segment and the entire journey. Now, speed is defined as the distance traveled over the time interval of the travel. And since we're interested in figuring out the speed for each of these segments, I'm going to use color codes to separate the different segments. So I'm going to mark this first segment with this green and call that segment 1. So speed 1 for that segment would be its distance traveled, which in this case is 12 meters, divided by the time duration that it took, which is 6 seconds, and so I get a speed of 2 meters per second. And for the second segment, let's use blue. So I got speed 2 for the second segment is the distance traveled, which is 15 meters, divided by time duration, which is 5 seconds, which gives me 3 meters per second. So I was faster in the second segment. And for the third segment, I'm going to use this dark red color. So mark that here and call that speed 3. And its distance traveled is 12 meters divided by the time duration 4 seconds, which also gives me 3 meters per second. So those are my speeds for each of these segments. And because speed is a scalar, all I have is magnitude, which is made up of a number and the unit in each of these cases. Now let's say that I'm interested in getting the average speed of my travel for the entire journey. One might be tempted, because we have these individual speeds, to just take the average of these three values, which you will do by adding the three values and dividing by 3 because there are 3 values going into the average. But that turns out to be wrong because the time duration of the travel in each case is not the same. So in order to figure out the average speed, we have to go back to the equation and say that the average speed of the entire journey is still the distance traveled for the entire journey divided by the time interval for the entire journey. So in this case, the distance would be 12 meters plus 15 meters plus 12 meters divided by the total time, which was 6 seconds plus 5 seconds plus 4 seconds. So when I add all this, I get 39 meters divided by 15 seconds, and that gives me an average speed of 2.6 meters per second. So that's the average speed of my entire journey. Once again, just magnitude which is made up of a number and units. Now, let's say that we want to figure out the velocity of the first segment of travel and the entire travel. Velocity, as shown here, is defined as the displacement over the time duration. And the arrows on top of v and delta x remind us that velocity is a vector, as is displacement. So now if I want to figure out the velocity of the very first segment, let me use the right color. v1 will be equal to delta x1 over delta t1. And so what's the displacement for the first segment? It's 12 meters, but remember displacement is a vector, so in this case it's 12 meters due east. Let's say that this is the traditional orientation where to the right is east and to the top is north. So I've got displacement of 12 meters east. That's made up of the magnitude 12 meters, direction east, and I divide that by the time 6 seconds, and that gives me 2 meters per second due east. There's my velocity for the first segment. You will note that the speed was 2 meters per second and the magnitude of velocity is also 2 meters per second. And that is true in this case because we traveled in a straight line. You will see in a minute that the magnitude of velocity and speed are not always the same. So I'll leave it as an exercise for you to figure out the velocity for the second and third segments. And when you do that, make sure that you specify direction in addition to magnitude. And now we move on to figure out the velocity for the entire journey. So I'll call that the average velocity for the entire journey would be the displacement for the entire journey divided by the time duration of the entire journey. So now we got to figure out the displacement for this entire journey. And as you will recall from the previous video, displacement does not care about the path of travel, and it is simply interested in connecting the starting point to the ending point by a straight line. And so the displacement in this case is just this 15 meters, and that's the magnitude of the displacement, and direction is due north. So now back to here, the average velocity is simply the displacement of the entire journey, which in this case is 15 meters due north, divided by the time duration of the journey, which is the entire 6 plus 5 plus 4 as we did before. So that's 15 seconds. And this gives me 1 meters per second due north. And there's my velocity, or average velocity, for the entire journey. And now notice that the magnitude of velocity, 1 meter per second, is no longer the same as the speed for the corresponding journey, because this travel is no longer in a straight line. There's one more thing I want you to note here. The direction of velocity, in this case due north, is the same as the direction of displacement we had, which was also due north. That's not a coincidence. Velocity and displacement will always have the same direction. And if you look at this equation, you can see why. Velocity is simply displacement divided by the time duration. Time duration is a scalar and moreover a positive scalar. And when you multiply a vector or divide a vector by a positive scalar, you do not change its direction. So velocity and displacement will always have the same direction. So this slice of physics should have given you a good understanding of speed and velocity. You now know that speed is a scalar, and it's the distance traveled divided by the duration of travel. Velocity, on the other hand, is a vector, so it has magnitude and direction, and it's related to displacement. So it's the displacement of travel divided by the time duration. Thank you.